In this video, we're going to try and differentiate y equals a to the power of x here. So to differentiate this here, look at this a. Zoom into this a here. We're going to rewrite this a as, hang on, we're going to rewrite this a as e to the natural log of a here. Okay, so rewrite this a here, rewrite it as this, and then to the power of x here. So this x here is here. So we can rewrite the a as this, and the reason why we can do this is because if you look at the function, hang on, if you look at the function here, so the function here is hang on, so here we are going to rewrite the a here, as e to the power of natural log of a, and then all that to the power of x here. So just looking at the a here, we are rewriting the a as this thing here. And the reason why we can do that is because if you look at the normal function, this is our normal function, and then we created the inverse version of that same function here. So we started out with this function. We created the inverse version. Now, from our knowledge of functions, if you put a into here, you get, let's say, b. But then if you get the b out and then put it into the inverse version of this thing here, you will get back to a. So what that means is, remember this here from our section on functions. If you put the inverse version into the original one, you're going to get back out what you originally put in. So if you put in, let's say if you put in a here, so looking at this here, it's saying put a into the inverse. So looking okay, in this case, we are going to put b in here. Okay, so looking at this here, we're going to put b into here. So looking at this bit here, it's saying put b into the inverse. Put b into the inverse. So look at this here. If you put b into here, you're going to get a. Now, if you get this a and put it into the original function, you're going to get back what you put in, what you originally put in. So my point here is that if you put b in here, then you're going to get b out. But then if you put x into here, then you're going to get x out. Now, looking at this here, looking at this here, it's saying put the inverse into the original. So now looking at this here, put the inverse, which is this natural log here, put this inverse into the original here. Don't forget this here is the original here. So if you get this, the inverse, and put it into here, then you should get what you originally put in there. So looking at this here, put this into this, so that will be e and then natural log of x. And then remember, if you put x into here, then you're going to get x out. My point is that this thing here, if you have a function, create the inverse function, and then you will always, you can create this. You can create this yourself. Don't forget, we can also switch this around. So looking at this, we are putting the inverse into the original function. You can also put the original function into the inverse. So now we're going to put the original function into the inverse here, and then this will also be true. So looking at this here, you can create yourself another formula if you like. So looking at this, put the original into the inverse. So put the original into the inverse. So that will mean that this is also true here. Hang on, this will also be true, e to the x here. So it's saying put the original function into the inverse. So this here should also be x here. So So my point is that looking at this here is saying put the inverse into the original. So put the inverse into the original. So that would be e. Hang on. Let me start again. Put the inverse into the original. So put the inverse into the original. So that will be e natural log of x will give you what you originally put into this thing here, which was x here. So this here is true. So that's what we're doing here. You see, don't forget, look, this a here is like this x here. So the whole thing here will equal x. So my point here is that looking at this here, you can have e and then natural log of whatever, in this case is a, and that will be a. So my point here is that we are rewriting this a here as this thing here. Well, anyway, from here we're going to rewrite the a as this, because you would start out with your original function, create the inverse, and then by using this property that we've developed in our section on functions, then we can get, well, anyway, this thing here is this thing here. Okay, these two are the same here. Yeah, so these two are the same. So the next step here is that, well, don't forget, this here is a constant. This here is just a number. The log of a is just a constant. It's just a number, like a number. Let's say 3, or it could be a number 7 or whatever. It's just a number. Okay. So whenever you have something to the power of something, and then to the power of something, remember from our section on indices, if you have x to the power of a and then you power it to the b, then it's simply x a times b for my section on indices. So here you've got something to the power of something and then to the power of something. So now you can just get these two and multiply them together. Okay, so this thing here will become this. Okay, because it's simply, looking at this, it's one thing to the power of another thing and then to a power of another thing. So that's going to be that thing, and then get that thing times that thing there. So you can multiply these two together. So yeah, so that would then, look, this thing multiplying with this thing. Don't forget, this here is a constant. It's just a number. So hang on, let's start again. So we want to differentiate this here. So rewrite the a here, just the a here, as this thing. So you've now got this thing to the power of x. Now by using this property here, x to the power of a and then to the power of b equals x a b here, then just simply get this, multiply with this, and then that will give you this. So here what you've got here is e to the power of one thing times another thing here. Okay. Now when you differentiate this with respect to x here, remember in some of the early exercises, if I were to give you something like this, y equals e to the power of 3x. Okay. Don't forget, this here is just a number. It's just a constant. So this here is like our 3 here. When you differentiate this here, dy by dx will equal 3. Remember, the 3 goes down here, and then the whole thing here stays intact. So that would be this. Dy by dx equals, the 3 goes down here, and then e to the power of 3x here. Okay, so this here, because this here is just a constant, when you differentiate this whole thing here, don't forget this thing here is e to the power of this times this here, and this is just a constant. So it's like me asking you to differentiate this, x and then 3. So well, we would switch these two around to visualize it like this, and then the 3 goes down in front. Well, anyway, to differentiate this here, that would then give you this. Okay, because at the moment you've got this thing to the power of one thing times another thing. So when you differentiate it, the constant goes down in front. So that's our constant there, and then the whole thing stays intact. This whole thing here stays intact. So when you differentiate this here, it will then give you this. Okay, and don't forget, this bit here was our look at this here. This bit here, okay, was hang on, looking at this here, this a here we translated to this here, and then this then becomes well, my point here is that this thing here is actually a to the power of x, because if you look at this here, we started with this here, and then we changed it to this. Don't forget, this thing here is really e to the power of x, l, and a here. This here is actually well, this here is a to the power of x. Okay, because if you look at this here, a to the power of x, we changed it to this, and this here is exactly the same. Well, from here. Let me start again. From here, that would then get you to here, and then from here, that would take you to here. So this, hang on, bear with me on this. So, hang on, this here is your a to the power of x. This here is your a to the power of x. And this here is also your a to the power of x. So this here is a to the power of x. Okay, so when you get to this stage here, looking at this here, this is a to the power of x. This is a to the power of x. So that would mean this. So when you come to differentiate it, the overall answer will be the natural log of a times a to the power of x. Don't forget that this here is a to the power of x. Okay, so when you try and differentiate this here, you will then get this, and then blah blah blah. That will then give you this. So overall, dy by dx is the natural log of a times this thing. So when we first started out, when we first tried to differentiate this here, I would normally say, when you try and differentiate this here, dy by dx would be some sort of constant times by itself. Well, this some sort of constant here is actually the natural log of a. This mystery number. So when we first started out, I would say to differentiate this here, dy by dx will be some constant times itself. Well, this constant here is actually the natural log of a. So if you, yeah, so this, well, also when we first started out, I would give you something like this, ask you to differentiate it, and then I would say that to differentiate this, dy by dx will be this complicated thing that we don't really understand times by itself. Well, this complicated thing here is the natural log of a, of whatever constant you choose here. Okay, so this complicated thing is actually the natural log of a. So what that means is that if you try to differentiate y equals this thing here, it will be the natural log of 2 times by itself here. Okay, so if you try and differentiate this here, it will be if you try and differentiate 3 to the power of x, it will be the natural log times by 3 to the power of x. So no matter what you differentiate, let's say 7 to the power of x, you always get to this natural log. It occurs naturally. So the natural log, just no matter what you differentiate, it always leads you back to this natural log. This thing just naturally occurs. Okay, so anyway, differentiate this, it will give you this. And even if you differentiate e to the power of x, if you try and differentiate this, you will get dy by dx equals some constant. Well, you're going to get some constant. Well, this constant here is the natural log of e. Now, if you translate this here, if you try and translate this here, your eyes should zoom in. Well, you've got to imagine, whenever you see the natural log, imagine that it's to the base e. Well, it is to the base e, but just imagine this e here. Okay, so when you translate this, you would say e to the power of what will give me this thing here, will give me e. Well, in this case, it's 1. Well, this thing here is actually 1. So it's actually 1 e to the x. Well, we would just write it as e to the x. We would just write it as e to the x. Okay, so when you differentiate this, it does give you e to the x. Okay.